Hello students of Amrit Indo-Canadian Academy. This is Amanpreet, mathematics teacher. Unfortunately, because of spread of coronavirus, everybody is made to stay home, but we can still learn at home staying safely. So today we are going to start with chapter 5 of class plus 2, that is continuity and differentiability. Before starting with the chapter, I would suggest everyone to open your books and open first page of chapter 5. This is the first page of chapter 5, continuity and differentiability. What do you mean by continuity? Continuity means a continuous function. A function which does not contain any gap or hole. In our real life situation, we say everything is continuous. But if we think long enough about our real life, we discover that actually lots of things are not continuous. Computers generally replace continuous things with discontinuous approximation. Another example we can take here, when a driver hits the car brake, acceleration gets reduced. Why so? Because speeds get reduced. So again acceleration becomes discontinuous. The stock market has lots of discontinuous jumps. So this is all examples where we think everything is continuous, but it is not. Before starting with the chapter, I would suggest everyone to draw this mind map in your copies. This is the mind map of continuity and differentiability, where we are going to study all these concepts: continuous function, differentiable function, algebra of continuous function, chain rule, logarithmic differentiation, and so on. And we will be covering it in the upcoming videos as well. So today we are going to take the concept of continuity. What is continuity? Continuity, as you can see this graph. In this graph, you will not find a single hole. When you will draw this graph in your books or in your copies, you will find that from C to D, you have not dragged your pen from the paper. So this graph is unbroken at M. There is no gap or hole in the graph of this function. So because there is no interruption, it means this graph is continuous. If you see the graph of your book on this page, figure 5.1, you will clearly drag your pen out of the paper, and then you will move from point 1 to point 2 on the y-axis. It means you have taken out the pen from the paper. This graph is discontinuous. So this is discontinuous graph. This is the graphical representation of continuity of a function at a point. How to prove that the function is continuous if you are not going to take any other example? This definition, continuity of a function. A function is said to be continuous at x is equals to a. This is a single point a. If limit x tends to a, f of x is equals to f of a. This is the first definition of a continuous function. You have to find the limit at x approaches to a. If you find the function is single, that is suppose 2x plus 3, a quadratic polynomial, anything like that. If the function is single, there is no breakage at any point. You have to simply find the limit x tends to a, f of x. If it is equals to f of a, it means it is continuous. If there are two or more functions, like, let me take an example here. Second point, if the given function y is equals to f of x has 2 or 3 definitions for different values of x. See here, x is greater than or equals to m, x is less than m. So at m, this function is dividing. There are two functions, greater than m, that is g of x, less than m, that is phi of x. So this is when the function is having 2 or more definitions. So what we do here? The concept here is, see the question, example 3. Discuss the continuity of function f of x defined by modulus of x. I have underlined what is modulus of x definition. F of x is minus x when x is less than 0, and it is equals to x when x is greater than equals to 0. This we have done in class +1, and here also definition is clearly mentioned. Modulus of x at x is equals to 0. It means this is the point where the function is dividing itself, that is x is equals to 0. Less than 0 minus x, greater than 0 modulus means plus x. So there are two functions now. How we are going to find its limit? How to prove that it is continuous? Now firstly we will find limit x tends to 0 negative. When it is approaching from the left hand side of 0, we will take function x less than 0, and the function is minus x. So we will take limit x tends to 0 negative of minus x, put x is equals to 0 here, you will get 0. Same case you will find right hand limit. Right hand limit, the right hand function is x approaches to 0 positive, that is x. So again when you will put right hand limit, you will get answer is equals to 0. Left hand limit is equals to right hand limit. Now we have to find f of 0. What is f of 0? This is 0 only. So three things you have to find when the function is containing two or three definitions. First thing, I repeat, left hand limit. Second thing is right hand limit, function at that point. If all these three things are equal, it means function is continuous. So these are the two things. Now see example 4. F of x is equals to x cube plus 3 when x is not equals to 0. Second is it is equals to 1 when x is equals to 0. We have to show that it is not continuous. The breakage point is 0. Now what we are going to do here, limit x tends to 0, f of x, either from right hand side or from left hand side, the function remains the same because it is not equals to 0. So we will put only one function here and we will get answer is equals to 3. And what is f of 0? By putting the point f of 0, this is 1. So left hand limit or right hand limit is the same, but f of 0 is 1, which is not equal. So this function is not continuous. I hope you understood what is the definition of continuity now, if it is a single point given or if 2 or 3 definitions are given. This is the definition 2 for 2 or 3 functions. You need to see it clearly, go through, revise it again and again, and you will come across with many questions. You have to solve these examples first, then follow with the exercises. See example 11 now. Find all the points of discontinuity of a function f defined by. Now these contains 3 definition: x less than 1, x is equals to 1, x greater than 1. It is not given whether you have to draw the graph or you have to prove by the help of definition. So you can go in either way. Both the things are mentioned here clearly in your book. Solution is given. This question has find out left hand limit first, x approaches to 1 negative. X is less than 1, which function will come? X plus 2. So in x plus 2 you will put x is equals to 1, you will get answer is equals to 3. Now take right hand limit. This is your right hand limit. Here you will take f of x as x minus 2 and put x is equals to 1. You will get minus 1. Very clearly left hand limit is not equals to right hand limit. So here function is discontinued. And what is the point of discontinuity? Point of discontinuity is 1. I hope you are very well cleared with the concept of continuity. Now see this example 12. Discuss the continuity of the function defined by f of x is equals to x plus 2 if x is less than 0 and minus x plus 2 if x is greater than 0. Here we don't have the value at x equals to 0. We don't have the value. It means if x is less than 0, we will get this line, and if x is greater than 0, we will get this line. What about x is equals to 0? Can you see this open circle? It means at x is equals to 0, function is not having any value. So this function is not continuous function, and very well it is written in this line, which is yellow underlined. Note that the graph of this function, we need to lift the pen from the plane of the paper. It means at x is equals to 0, we have lifted the pen, and then we have again put the pen on the paper and we draw for the function x is greater than 0. Is this clear, everyone? Now comes to example 13. Now see this function. Discuss the continuity of the function f given by. Here if you will see f of x, x is greater than or equals to 0. Here x is greater than or equals to 0. So it means we can say at x is equals to 0, again the function is defined. X is equals to 0, the function is defined, and x less than 0, function is again defined. So function is defined for all values of x. If you see the graph here, the function is defined for all values of x at 0 also. So this function is continuous because we have not lifted the pen from the plane of the paper. In this question, there is no hole or gap, no interruption while drawing the graph. This is the continuity of a function. Now example 15 is very important. In example 15, see example 15. What is in example 15? Find all the points of discontinuity of greatest integer function. Let me explain what is greatest integer function. Here you can very well see the graph of this. What do you mean by greatest integer function? Greatest integer function is when x is equals to 1. So we say when x is equals to 1, the value is 1. But what about when x is less than 1? When x is less than 1, चाहे point is 0.3 or the point is 0.7, anywhere the value of this function is 0. This is the value of the function. So whenever x is less than the 1, its greatest integer is always 0. And whenever x is less than 2, what is the minimum integer? That is 1. So whenever x is less than 2, the function is having value is equals to 1. So similar way, if the function x is equals to -1, so what is the greatest integer when x is equals to -1? Everywhere the value will be -1. But if x is greater than -1, so greatest integer will be 0. I hope you understood what is the greatest integer function. So what is this question? Find all the points of discontinuity of greatest integer function defined by f of x is equals to bracket x. This is the closed bracket, which is the sign of greatest integer function. And you can very well see the graph. You have lifted the pen so many times, so it means this function is not continuous. This is discontinuous at every integer. It is very important to write at every integer. Now let's come back to next page. The topic is algebra of continuous function. If you see the algebra of continuous function, now there are two continuous function, f and g. Addition of these two continuous function is continuous function. Subtraction of these two continuous function is again a continuous function, and product of these two continuous function is again a continuous function. What is composition of two continuous function? What do you mean by composition? This is very important. Composition is, now see here everyone, if you have two functions f and g, these are two functions. If these two functions are continuous, then what is FOG? FOG is f of g of x. This is again continuous function. If g of f, is this continuous? Yes, this is composition of two function. It is written as g of f of x. These are also continuous. So this is the meaning of composition of a function. And if you see your page, you will find that algebra of continuous function. In this page, f plus g is continuous at x is equals to, f minus g is continuous at x is equals to c, f dot g, product is also continuous, and division is also continuous, provided denominator should not be equals to 0. So g must be continuous at each and every point in its domain. Denominator should not be equals to 0. Proofs will not come in this. Next question is, which type of functions are always continuous? Rational function is always continuous. Polynomial function is always continuous. Trigonometric functions is always continuous. See example 7. Now discuss the continuity of sine function. How this trigonometric function is continuous? Proof is given here. Here you have to just find the limit f x approaches to c f of x. Once you will find the limit x approaches to c f of x, you will put f of x as sine of x. Now limit x tends to 0, it means x approaches to c plus h. Apply the formula sine of a plus b, that is sine a cos b plus cos a sine b. And when you will apply the limits, you will get it is equals to sine c, which is equals to f of c. So it is satisfying the definition limit x tends to c f of x is equals to f of c. Hence this is a continuous function. So every time you can prove that trigonometric functions are always continuous, whether in case of cos, whether in case of. Now exercise 5.1, question number 3. As you can see this question number 3, examine the following functions for continuity. In this case, there is no point is given where you have to find that function is continuous or not. So what you are going to do is you are going to find the domain of each and every function. For example, a part. If you see the a part here, you will see that function is x minus 5. So here in x minus 5, it is a polynomial function. So this polynomial function has a domain R, that is real number, because it can exist in any real number. So you have taken one point c in its domain belonging to a real number, and you have to take limit x approaches to c, that is any number. And when you put any point here, you will get the function of the type c minus 5, which is equals to f of c. Hence this is continuous function in its domain. Take the case of third part. Now this f of x is equals to x square minus 25 upon x plus 5. We very well know that denominator can't be equals to 0. So if denominator can't be equals to 0, it means x cannot be equals to minus 5, or x can be any number except minus 5. So what is its domain? Any real number minus 5, because we are neglecting minus 5 here. So if you take any point in its domain, so function is continuous everywhere. This is the question. Examine the following functions for continuity. You have to find its continuity, where this function is continuous. So you need to search for the domain. What is the domain of the function? Then you have to see whether in its domain the function is continuous. Yes, the function is continuous in its domain. This is all related to question number 3. Now comes to question number 6. This is question number 6. F of x is equals to 2x plus 3 if x is less than equals to 2, and it is equals to 2x minus 3 if x is greater than 2. In this question, the function is distributed in 2. This function is distributed at 2. It contains two definition, that is 2x plus 3 and 2x minus 3. So what you are going to do, you have to find the point of discontinuity. It means the function is breaking at 2. You have to find whether left hand limit is equals to right hand limit or not. So here in this question x is less than 2. So what you will be finding? You will be finding limit x tends to 2 negative. It is equals to limit x tends to 2. Here f of x will come, which is the function which is approaching towards left hand side of x, approaches to 2. This is 2x plus 3. So you will write here 2x plus 3 and then you will put its value 2. 2 2s are 4. 4 plus 3 is equals to 7. So you will get answer is equals to 7. This is left hand limit. This is left hand limit. Now let us find right hand limit. Limit x approaches to 2 positive. F of x. What is the function? That is 2x minus 3. So it is equals to limit x approaches to 2, 2x minus 3. Now put here x is equals to 2. When you will put 4, 2 2s are 4 minus 3 is equals to 1. So clearly you can see left hand limit is not equals to right hand limit. One thing you have to note it down. Here I have put negative sign, that is left hand limit. Here I have put positive sign, but here I have not put any sign. Why? Because I have taken that function. This is left hand function, this is right hand function. Once you have taken the function, then there is no need to put the sign. This is the point of discontinuity, because at 2 the left hand limit is not equals to right hand limit. This is all related to question number 3. Now let's come to question number 9. In the question number 9, f of x is equals to x upon modulus of x when x is less than 0. It is equals to minus 1 when x is greater than or equals to 0. So here if you clearly see x is less than 0, why modulus is given here? If x is less than 0, we know that according to definition of modulus of x, if x is less than 0, then modulus of x is equals to minus x. We knew it. So we can rewrite this statement in the form of this statement. Here it is written x of modulus of x as minus of x. So automatically it becomes minus 1. I hope you are cleared with why modulus is given. It is just to make us fool, but we are smart enough. We can rewrite the statement because x is less than 0. So modulus of x becomes minus of x. Now here less than 0 and function is minus 1, greater than 0 function is minus 1, equal to 0 function is minus 1. So everywhere the value is minus 1, whether x is less than 0, whether x is equals to 0, or whether x is greater than 0. So this is a continuous function because left hand limit is equals to right hand limit is equals to function at that point. Next comes to question number 17. In this question number 17, find the relationship between a and b so that the function defined by f of x is equals to ax plus 1 if x is less than 3, it is equals to bx plus 3 if x is greater than 3. We have to find the relationship between a and b. What is the value of a and b? Here the function is given that it is continuous at x is equals to 3. So what you are going to, what CBSE demands from us, that you have to write the proper definition. Once you will be able to write the definition, you will be getting 1 or 1.5 marks. Otherwise, you will be losing these marks. So how to write the definition? Since this function is continuous at x is equals to 3, so you will write left hand limit is equals to right hand limit is equals to f at 3. So this is the definition of continuity, and you will expand this definition. Limit x approaches to 3 negative, f of x is equals to limit x approaches to 3 positive, f of x is equals to f of 3. You will find one equation from here, and when you will put it is equals to 3, you will get 3a plus 1 from here. So you can solve either these two, or you can solve either these two. You will be getting the value of a and b. This is how you are going to attempt all questions like this. And now if you have to solve any question of point of discontinuity, this is explained like question number 23. This is explained as previous question, and now you have to solve this exercise yourself. Till then, practice, practice and practice, and stay safe, stay healthy.